Hi students, today I am going to explain alternating current through a pure resistor. That means when alternating current passes through a resistor, what is the phase difference between the electromotive force of the AC and current of the AC. Okay, let us go for that. Let us consider a circuit of resistor R. When I am using the word pure means actually there are main components of the circuits are LCR. L means inductor, self-inductance, C means capacitance of the capacitor, R means resistors. So, in future classes I am going to explain the combination of inductor, capacitor and resistor. Now I am taking only resistor. That's why I am telling word pure resistor. When a pure resistor is connected to a AC source, AC source means you know already the symbol of the AC source is this. When current, because of electromotive force, variable electromotive force, the current, variable current also produced here. Clear? So now you know at any particular instant of time the electromotive force of in the circuit is E equal to E naught sin omega t. This is already you know this. Instantaneous electromotive force in is equal to peak value of the electromotive force sin of omega t. Okay, you know this already, this equation. Now I am going to write this E can be written as I into R because then the current is passing through it. For example, at a particular time of instant, the current is I. Assume that at a particular instant of time, the corresponding current is I. Then how can you write this equation? E can be written as instantaneous electromotive force is current in the resistor into resistance of the resistor. But you know the current may be changing through it. The current value go on changing. I becomes I1, I2, I3, I4, I4. After some time it becomes peak value. But the current may be changing but the resistance is constant. That's why you can write it as I naught into R. The peak EMF is nothing but peak current into resistance. The R is not changing but the I is changing. Then sin omega t. Then if you take the R common here, then R gets cancelled. Then I is equal to I naught sin omega t. Now if you observe this equation, this is the equation. This is the relation between the electromotive force, instantaneous electromotive force in the purely resistor circuit. This is instantaneous current depending on the peak value. Now this is the current relation, this is the EMF relation. If you observe this, the E is equal to E naught sin omega t, I is equal to I naught sin omega t. This angle is not changing. What is the meaning of this? The electromotive force and current both are in phase. What is the meaning of in phase? So for example, if you take this is x-axis and y-axis, if you are giving the electromotive force like this is the electromotive force because it's the alternating current electromotive force na. So assume that its peak value is E naught. Obviously this must be minus E naught. This is another side. Minus is indicating only direction. Now assume that the electromotive force, one of the wave is taken as like this. Then how can you take the current? If you see this, the sin omega t sine. For example, at t equal to 0, the current is EMF is 0. Then here omega t and here also omega t. That means at t equals 0, if the electromotive force is 0, for example T1 equals 0, E1 value is 0. But at the same time the current is also 0. That means it is started here. After T by 4 seconds, that means this is total time taken to complete one cycle is time period. After quarter of the time period, that means exactly after T by 4 seconds, if the electromotive force is E naught, then current is also I naught. Okay. Now after some time, after T by 4 seconds, if the current is the electromotive force is some value E2, then current is 0, electromotive force is also 0. After 3/4 of the time period, if this is minus E naught, this is minus I naught. The current is also changing. So that means you can take like this. That means in the two graphs I am writing in same way, only in one graph. So actually when we are taking along the x-axis I am taking time, along the y-axis I am taking EMF. But instead of taking the electromotive force and time graph, current and time graph separately, I am taking in the same place. That means because you know current is nothing but E by R. If something denominator is assume that if the R is more than E, then current is less. That's why the peak value of the current is less than, numerically less than the peak value of the EMF. It may not possible every time, but I am considering the numerical value of the resistance is more than the electromotive force. That's why I am assuming that the I naught is less. Obviously it is more. Okay, here maximum current peak value and maximum EMF both are at the same time. Current 0, EMF 0 after t by 2 seconds. After t seconds again they are coming to 0. So in this way, every time if you see that it is like a transverse wave, the crest and crest are coinciding, trough and trough are coinciding. At every instant of time, these two waves are like a constructive interference. You know it already. Constructive interference. It is similar to like that. That means they are always in phase. In destructive interference, if the EMF is like this, the current may be like this. So that means I want to explain this peak value of the current and peak value of the electromotive force. Instantaneous current and instantaneous EMF with constructive interference, but it's not, may not be related to that. Okay, just think about it. That means crest and crest coinciding, trough and trough coinciding. So like this. Now, if you see this in phasor diagram, for example, if I am taking electromotive force E naught here, this is the time. If it is making an angle omega t, if it is making an omega t or particular angle, if it is taking, the current also take the same angle. That means E naught and I naught, the phasor, this is called phasor diagram. Phasor diagrams means this is the straight line which is showing the gradual increase in the electromotive force. This arrow mark is called phasor diagram. It always rotates anti-clockwise direction. If you see at exactly when electromotive force is maximum, the current is also maximum. That means these phasors are coinciding.